3.1 Engineering. Here are our guiding questions. What is engineering? What are the different types of engineering? And how do engineers do engineering? What is engineering? Engineering is the process by which solutions are designed to solve problems. The big difference between science and engineering is that science is how we understand the world, the naturally occurring world. Engineering is how humans invent technologies or problem solve with issues that we have in the world. And so science is more of just understanding and knowing how the world works, whereas engineering is how are we going to help humans fit into that? How are we going to build technologies that make our lives easier or more fun? So engineers use math and science to invent solutions to problems. A lot of times people think science and engineering are the same thing. They're not, they're kind of counterparts. So we use engineered technologies to study science, and then we use our understanding of science to develop new technologies through engineering. We use math to do this, and we use science to do this. So here are the different types of engineering. Electrical engineering, these are the people who build new circuits, they study electricity, and then use their knowledge of electricity to make technologies that make electricity more efficient. So if they're developing solar energy or they're helping with internet, and so we're finding ways to send electricity through the United States. For example, 100 years ago, we didn't have electricity in every home, but as time is going on, we are creating new technologies to make electricity more efficient, make it go through the wires better, have better electricity stations all throughout the United States so that we can have that technology. Another example is civil engineering. Here we have a bridge, so bridges, roads, even buildings. I know we think architecture. Architecture is more the design of the building. The civil engineering is more how do we build the building. And so things that people use would be civil engineering. Biomedical engineering, so if there's things like a pacemaker or prosthetic limbs, anything that is human invented technologies that help humans live or survive, even the tools that we use in the hospitals for surgeries, that's biomedical engineering. Environmental engineering would be things that humans have created or invented, systems that we've made. Here's a water treatment plant, things that we do to help keep the environment clean while also making sure that we're making the technologies and things that we want. So that would be environmental engineering. Mechanical engineering, I don't have that on here, but those are mechanical things. And so even like building roller coasters or vehicles, that's a type of mechanical engineering. Chemical engineering would be things related to chemistry. Making new foods, that's a lot of chemistry and understanding those molecules and how they affect the human body. Mixing chemicals to make new chemicals, that's chemical engineering. Coming up with new fuels for vehicles, that would be chemical engineering. Construction engineering kind of goes with the civil engineering I mentioned earlier. They're the people who are building the homes. They're looking more at the mathematical side of it. So an architect might design a building, but then the construction engineer has to check to make sure that the building can be safe and secure and built the correct way. So how do engineers do engineering? They use something called the engineering design process, and this is real. This is definitely, I've talked with engineers before and they said, yeah, we actually go through this cycle, sometimes hundreds of times. So the first thing you need to do is observe a problem, ask a question like, why? Like, we need to create something to fix this problem. And then you imagine, this is like the fun part. This is where you come up with things that might seem insane or crazy. You brainstorm. A lot of times you do this with other people. You do it on your own, then you get together and you share your ideas. Then you plan. Now, the planning stage, I don't want to say it's the most important, but it is very important. You should identify your criteria. That is, what does it need? I guess that kind of goes with requirements. So criteria is like, if you know you need to get over the bridge, that's a criteria. It needs to hold so much weight. That's a criteria. Then you also need to identify the constraints. Those are the limits to the design. You are not going to always have as much money or resources as you want. You have to figure out what are your limits and then make your design fit those limits. So you figure out your plan, then you create the thing, you test it, and you keep track of the results, and then you make improvements. And then you go back through the cycle, and you continue to do this until you have a solution to the problem. And the thing I want to make mention of here is a lot of our technologies that we've invented, the engineers that came up with this, one is a team effort, and two, they went through the cycle hundreds, if not thousands of times. And a lot of the technologies that we have, they're not done going through the cycle. Think of a cell phone. If we think that cell phones are done, we have the best models of cell phones, we don't need to do this anymore, we're wrong. They're going to continue to think of what are ways that we can make and improve cell phones for consumers. And so the engineering design process is a cycle, it's never ending, and that's it.